Good afternoon, everyone. Welcome to Android Emulator section. My name is Sam Lin. I'm a product manager in Android Emulator team. Join me on stage are Frank and Hoi. How many people here have been using Android Emulator? Show me your hands. Wow, that's great. Good to see you guys here.
Nice.
Today, we're going to tell you about the new feature and show you a few use cases. Hopefully, that will inspire you to a new way to using Android Emulator to improve your productivity. If you haven't using Android Emulator, the first tip for you, you can download Android Studio today and try it out. Android Emulator has always been part of SDK from version 1. Can you believe it? It's already 11 years ago. I still remember my first Android app. I built it with SDK 1.5. Back then, Android Emulator was slow. I ended up need to using a lot of physical device. But in the past few years, we have been systematically improve Android Emulator. 3 years ago, we rebuilt the foundation to make it much, much faster and add a bunch of features so it's easier for you to test the application with it. 2 years ago, we added the Google Play Store support, so you can actually test your application distribution flow end-to-end. Last year, we added a Snapshot. You can actually easily switch between different system states to help you do different tasks quickly. And this year, we add the foldable support. You can start to help user to unfold the future with your application. With all those changes, we are actually focused on 3 key principles. The first one is fast. A good emulator should be fast, so you can actually get things done quickly. The second one, a good emulator should be high fidelity, which means you can test the application just like you using physical device. Finally, a good emulator can be versatile, so it can actually help you finish different kind of tasks quickly. At Google, we believe fast is better than slow. That's why we start making Android Emulator fast to save you time. So how do we know something is fast? Obviously, UI is a big part of it. Because nobody likes using janky UI, we're using this to measure our development. This chart shows you how many frames per second a device can draw when they run the benchmark application. As you can see, Android Emulator is slightly faster than Pixel 2 XL, which means running application on Android Emulator is pretty fast now. In case you're curious, I'm using the notebook, have a quad-core CPU, 60 GB of RAM, flash storage, and a good GPU. Frank, can you tell us how we make Android Emulator fast?
Sure can, Sam. So to start out with, the biggest thing that's changed about the Android emulator versus the emulator from many years back is we stopped translating every single instruction of the guest operating system to x86 one at a time. So it used to be the case that you ran an ARM Android guest operating system on an x86 host machine. And that required the emulator to look at every single instruction and decode them while translating them to their x86 equivalents. And this is actually how most emulators work these days because of this architectural mismatch between the guest operating system CPU architecture and the host CPU architecture. But with the Android emulator, we decided to run x86 on x86. And that gives you a really powerful technology, CPU virtualization, which is a set of hardware extensions for your CPU that let you simply direct your computer and run the Android guest operating system's code directly, well, with almost no translation. So these technologies are called hypervisors, and we use Haxim on Windows or Windows hypervisor platform if you want to run with Hyper-V. And on Mac, we use macOS Hypervisor Framework, and on Linux, we use KVM. So this lets you run the Android guest operating system with nearly the same CPU performance as your host machine. Next, Android, to give a brief bit of background, does almost all of its hardware rendering operations using the OpenGL ES or Vulkan APIs. Previously, we used to run these graphics APIs in the Android guest operating system using the CPU to render, while these APIs are meant to be used with hardware GPUs. However, hardware GPUs is now the default setting for the Android emulator and has been for quite some time. And we've recently started supporting the Vulkan and OpenGL ES 3.1 APIs in Android Q. We do this by leveraging GPU virtualization techniques that let you use the full power of your host GPU in order to run Android emulator.
That's great.
Thanks.
So, during the development process, you actually interact with Android device quite often. For example, you testing the app, you installing application. All those interaction is basically done by Android debug bridge to help you transform data from the Android computer to Android device. The way to measure this performance, you can easily done by pushing an application or a file to Android device. On this chart, it shows you Android emulator can actually doing this much faster. Frank, can you show us why is that?
Sure. So if you're using I'll go back to the slides. Sure. If you're using a real device, you often need to connect it with USB. And USB contains a few complications here and there. So you'll need a USB cable upon USB cables, USB 2 or 3, USB drivers that work well with your macOS or Windows system especially. And depending on your device, it may or may not support the latest and greatest USB protocols that are fast. Now, if you're using the emulator, everything takes place on your host machine. All of your ADB pushes and all that, they basically talk through a virtual TCP connection over shared memory. So you're essentially limited by your host machine's disk I/O when you're transferring files over ADB. So that's why we can get ADB push to be so fast.
That is great. With that performance advantage, you can actually get things done faster. For example, when you install the application, this chart shows you emulator is actually faster for sample application. Of course, if your application is much bigger, Android emulator will save you more time. We also know you normally do quite a lot of things on your computer. And sometimes you just need to close Android emulator to do some other thing. But for Android to boot up, it actually takes the full boot up sequence, which can take for a while. That's why we add quick boot, which will resume Android emulator in a few seconds. Switch to demo, please.
Thanks. So I'll show you the difference between a normal boot up of the device and the emulator. So this AVD called cold boot, you can select to cold boot it right now, and you see this black screen here, cold boot selected by user, and guess we got to wait for a while before a Google logo comes up. But I have this other AVD called quick boot, where if you just press play, I have a previous snapshot saved here, and it's able to just come up right away, while the other emulator is still in the middle of its boot up cycle. And the quick boot emulator is already interactive right away. So this makes it really easy to set your device in some state, then you need some more resources or whatever, you close the emulator and you launch it again really quickly. Also, this is our most heavyweight hardware profile, the 8-inch foldable, and it was able to launch in much less time than the cold boot using our snapshots technology. Thanks. Back to the slides.
Wow, that's quick. OK, we also try to look at what kind of thing Android emulator can do faster than the physical device. For example, our friend on AR Core team, they love to using Android emulator to test their application. But just like me, they are lazy. They don't want to do manual tests every time they change the application. That's why they add a new feature called AR Micro. This allows you to play back a preset breaker. So you can do sanity tests quickly and precisely. Switch to demo, please.
Thanks, Sam. So for those of you who went to the keynote today, there were some really cool AR demos, right? And it kind of looked like that you really needed a real physical device in order to develop and test AR apps. However, on the emulator, we've been working with the AR Core team to enable you to test and develop AR Core's apps without needing a physical device. We call this the virtual scene camera. It is a virtual camera device that exposes a virtual environment. This virtual environment has textures that can be picked up by AR Core tracking algorithms, and thus can function largely to the needs of your AR Core application. But recently, we've added a feature called AR Core macros. This is because when you're running this virtual scene camera, you might end up doing a lot of repetitive motions, like maybe resetting to the initial precision, which we can do now with a button press, or tracking a horizontal plane in order to get the tracking plane to show up so you can place your AR Core models. Notice that while the playback is going on, the camera is changing its viewpoint according to the macro's instructions. And while that is going on, all the right sensor signals are sent to the guest so that your app will think that it's in a real environment. Thanks. Now back to slides.
Thank you. I think I want to add on that one is if you look at the mobile device, the powerful mobile devices actually interact with the world. That means you need to do a lot of tests manually. And we try to explore if Android Emulator can help you on that. This is just a starting point. In the past few months, we have been working on Project Marble, which polished Android Emulator. In the new release, we actually improved the efficiency for Android Emulator. For example, when device is on the charging mode, Play Store can automatically update application whenever there's a new version available. This is actually one of the key reasons Android Emulator taking a lot of CPU and consume a lot of power. As you can see on the chart right now, to avoid this, the team actually properly enabled the battery mode by default, which will eliminate application auto update and the background task, as you can see the blue line. But don't worry, you can still turn on application auto update whenever you like it. Just switch to AC mode. Next, let me hand this over to Hoi to tell you more.
Thank you, Sam. So we have just talked about how do we make the emulator nice and fast. The next thing that we need in an emulator is, well, actually, we need to trust it. Otherwise, there is very little point in you testing anything on the emulator. So the team have done a lot of work to make sure that the behavior of the emulator is the same or very similar to the physical device. So what are the three things that we've done? Let's go through them. The first thing is we start off with the same code base as a physical device. And when we say the same code base, we don't mean half a stack. We mean the whole stack. And that includes the hardware abstraction layer, as well as the Linux kernel. In addition, as Sam and Frank mentioned earlier, we have made it super fast for Windows, Mac, and Linux by paying a lot of attention to performance so that you can get the same feel using the emulator as a physical device. So, OK, fine, you've done the code. But as all good developers do, we test it. So we are now running over 900,000 compatibility tests. And these are the same tests that pass with your physical phone. So your physical phone passed these tests, and the emulator passed the same tests. And you might go, yeah, Hoi, 900,000, big number. What does it actually mean? Can you give me a concrete example where this makes a difference? So this is one of the tests that the previous generation of the Android emulator have failed. When you're displaying a YUV image, instead of displaying the blue 128, actually we sneakily feed in blue 132 and hope that you didn't notice. Well, you may not notice it from this screen, but your integration test would. And a lot of integration tests actually fail because of this. And why is that? When we go through the code base, these kinds of things were in it. We basically run one set of code if it is a physical device, and we run a completely different set of code if it is running in the emulator. So the team worked diligently and went through all the code color within Android to take these kind of codes out. So the result is when you specify blue128, you can be sure that it is giving you blue128. And if this doesn't convince you, maybe this date will. From the 1st of August 2019, as we all know, when you're submitting a new or update app to the Google Play Store, you will need to submit a 64-bit version. And if you haven't got a 64-bit device to hand, well, the Android emulator is your friend. Woohoo! So we have done testing, we've done our code base. How about things that you normally find on a physical phone? The team have done such a good job that the Google Play Store actually now trusts us to basically put their store on our phone. And what this means is you can actually truly test the app end-to-end, not just installing it and run through the flow within your app, but through all the things that are around the app as well. So a typical end-to-end testing scenario might start with an ad on a website on another app. When you click through, it will actually take you to the Google Play Store, and you can install the app right there. After that, you can sign in with your Google account or any of the social network that your app may support, because you can now install those social network apps on the emulator. If your app supports in-app purchase, you can also test in-app purchase in the emulator itself. And last but not least, all of us want our apps go viral. You can now share your app within the emulator and test that flow as well. So this is truly end-to-end testing. Woohoo! We heard a couple of claps. Excellent. So we've built the emulator super fast, and hopefully what I've convinced you is we have done a lot of work in getting back your trust on the fidelity of the emulator. How does it actually fit into your workflow? So let's talk about the versatility of the emulator itself. My own personal favorite feature is Snapshot. How many of you have basically installed an app, run through the flow, and then you realize, oh, actually I need to test it again, which means uninstalling your app and then basically reset up the entire thing again? Show me your hands. Yay! OK, so this feature is for you. After you have done all your setup steps, you can just tell the emulator to save a snapshot. And when you're ready to test again from exactly that particular point, you can just click on the one button and basically get right back to that point. Can we switch to the laptop, please? And Frank will demonstrate this for us. Over to you.
Thanks, Hoi. So I'm going to demonstrate this little thing where oftentimes snapshots can be useful for when you want to put your device in a particular state that is easy to get back to. This is especially going to be an issue in new foldable devices where split screen may be more prominent. So to demonstrate split screen first, I'll show you how to set it up. I'm going to start this multi-window playground app that does different things depending on your split screen settings. I'm going to activate split screen by pressing the app icon and selecting split screen. So now we have another window pane in which we can potentially launch a different application. Now, when you're testing this multi-window app, one of the things that might happen is you might launch an unresizable activity. And now, when you launch that, the system has no choice but to cancel split screen mode and put you in this fixed aspect ratio mode right here. And now, if you want to retest that original scenario, you need to click through what I just did again. But with the snapshots, once you have saved your device in a state where a state that you like, you can click play down here, and it will load the snapshot. And I guess it's still loading, but yeah.
That is live demo.
Yeah.
Yay!
So anyways, you load it, and then it's in the state that you were using before, and you can then pretty easily set up many other states here and also change the name of your snapshot and everything. So that's cool. All right, back to slides.
Cool. Thank you, Frank. So in that scenario, you might argue, hey, it's just 2 steps to split the screen. But as many of you who have raised your hand before, you might spend 5 minutes setting up your app to a particular state before you go on a test. And what I usually do as well is I will actually run through the flow of my app and take several snapshots along the way, which saves me a ton of time when I want to retest a particular bug fix or when I want to just add a new feature at a particular place, and I can go right back in. So apart from Snapshot, and we have done a lot of testing, so now it's your turn. And what's better than running one test? Running multiple tests at the same time. So another feature that the Android emulator support is having multiple instances running different tests at the same time. Another way that I use this is to test the same app on different screen configurations. And this doesn't just work for the phone form factor. It also works for large screen and foldables as well. And another thing about the emulator is quite often you have different devices available in different geographies. And in this particular case, foldables are actually pretty hard to get, even when you're working in Google. So what happened with the foldable at the moment is I have to say my first taste of foldable and testing my own app on foldable is actually on the Android emulator. So I strongly encourage you to take a look. And I'm sure that you have got many more questions about this new form factor and also the larger screen apps. So we have got a special session today at 5 p.m. where you can check out the latest best practice about building for foldable and large screen. I strongly recommend that you attend that session. So we have different tests running at the same time. We have different screen configuration tests. What about other things you can do with multiple instances of the emulator? Another one of my favorite is basically running different instances, but running different API levels. I'm sure that a lot of you will go through the behavior change page of every single Android release and find that, oh, you have changed this. Let me test that. This makes it super easy to test the different API levels, such as in this example, the share screen have been changed in Android Q. So you can now test it right next to an Oreo device, or emulator, rather. So Frank, can you show us how this could be done, the different types of testing?
Indeed.
Let's switch to the
laptop.
computer.
Thanks, Hoi. So there are many different things that you can do with multiple instances of emulators, and there are different degrees. So the first one, which we introduced recently, is a way to run more than one instance of the same AVD. Note that previously, you needed to create more than one AVD if you wanted to run more than one emulator in parallel. Well, now you don't have to. I have a terminal open with a script to launch multiple instances of the same AVD called launch_multi-instance.sh. Now you'll notice that this command line is pretty typical, except for the fact that you have this new command line flag here, read only, and the AVD name is the same in both cases. Now, why is this significant? Well, read only will essentially let you launch more than one instance of an AVD at the same time. So when we launch this script, it'll launch both of them in the background. In addition, if you add the read only option and you're booting off of a quick boot snapshot, you're only going to restore to that previous snapshot and discard all of the changes to the snapshot once you exit. So once you launch it again, you're going to be in the same exact state that you started with when you last saved the quick boot snapshot. I will demonstrate now. So this is actually 2 emulators, and they're all running independently. And if we look in, say, let's clear the terminal, AV devices, we have 2 devices. And we can run integration tests as if we actually had 2 devices. So for example, if I try to run this instrumentation test here, the ADB shell AM instrument, it can run on parallel on both devices at the same time. So one test is running on one device, and a different test is running on the other device. So you can get kind of test sharding pretty easily. One last thing to mention about resuming these AVD clones from the same snapshot is that their RAM is shared until it's written. This is called copy on write. So this is also using less RAM than if you started two independent AVDs. So that's the same AVD instance, but what if you're testing multiple screen configurations? Well, let's launch a normal screen configuration and one of the new foldable ones. Okay, let's see. And if we run the Santa tracker in the emulator with normal screen configuration, it comes with a particular layout. However, if you launch the foldable emulator, and then inside that emulator, you launch the same app, you can often get a different layout. So running multiple emulator screen configurations this way lets you really quickly test multiple screen configurations quickly. And since this is a foldable device, I have to also demonstrate the folding feature. So with a foldable device, the app layout will change a lot if you fold and unfold. And so the foldable virtual devices give you a quick way to test this. All right, so that's for different screen configurations. What about different API levels? In Launch SDK Compat, I will be launching two emulators. One of them is an API 27 Oreo. Another one is a QImage. So once we launch them, both of them are in read-only mode. So once you can integrate this into your CI pipeline, all the changes are discarded on exit, so you can launch it the same way the next time without wiping any data or installing any apps or restoring any state. Anyways, let's see, sharing shortcuts test. Test that sharing app that Hoi was showing earlier on both of these API levels in parallel. And we can indeed get one of the tests to fail and one of the tests to succeed, depending on the API level. So there you have it, multiple instances. They will let you shard your test with the same AVD, let you run multiple screen configurations in parallel, and run tests on different API levels in the same manner. All right, back to slides.
Yay. Isn't that fantastic? So hopefully we have convinced you that you should run all your tests in multiple instances. Another way that can really help is to run actually those tests in a headless mode, so you can save even more memory. And by our count, you will save about 100 megabytes if you're running it in headless mode. Frank, can you show us?
Indeed. Let's switch to the laptop. So one of the complaints about the emulator that we heard a lot is how hard it was to deploy in many common continuous integration, continuous delivery pipelines. In the recent versions of the emulator, we've tried to take a hard look at the emulator's dependencies on the Linux system and try to strip down as many of them as possible, starting with removing the usage of UI libraries. So we used to depend on things like X11, Pulse Audio, Qt, but now we give you the option to run the emulator in a minimal dependency headless build. So in order to use the headless build, let's see, qp3 headless.sh. In recent emulator versions, we provided a new emulator binary called emulator-headless. What this is an emulator that doesn't use any UI, but still does all of the rendering and everything else just as the normal emulator would, so that you can get high fidelity results by making it and easier to deploy. We explicitly list the libraries on Linux that this depends on. There's only like 7 of them, like ld.so and various essential things. So hopefully we can this makes it easier for you to run CI pipelines with emulators. Launching this, you'll notice that it's launched, but there's no UI. But if we go back to Studio, Logcat is running. Everything in your tests will behave as if there was a real device there still. You just have a minimal footprint that is easier to deploy. All right, thanks. Back to slides.
Ooh. Let's go back to slides, please. And I'm sure that a lot of you really want to find out what's the latest best practice on building testable apps. So on Thursday at 11:30, we've got another session for you. Please go there for the latest information. So we've went through the day-to-day development using Snapshot to having multiple tests running, integration tests, or maybe your continuous integration system running them. OK, so after your app launch, I am sorry, but in real life, the Android not responsive and crashes, unfortunately, do happen. And one of the ways that I use the emulator is to basically, in conjunction with the Google Play console. So at the Google Play console, you will see the different crashes or Android not responsive being divided into different sections. One is potentially your own app version. Another one is the different devices that are experiencing these kind of problems. And then third is the different API levels. And you might also want to have a look at the kind of user feedback, whether positive or negative, depending on the device as well. And this is the kind of workflow that I would go through. So the first thing that I would do is I'll have a look at, are there any particular device that is causing a lot of crashes or Android not being responsive? And if it is, I would look up what is the screen density. Is it HDPI, or is it other different screen size or density? Once I get that, I will launch an emulator that matches that and just do a sanity test. That's usually very quick. Much, much faster than me kind of going down to the device lab and checking a device out. If it's not that, the next thing that I would do is to look at the API level and see whether the crashes is actually caused by differences in behavior of the different API levels. While the emulator we think is of very high quality, there are always instances where you do need to go back to physical device. But hopefully what we have done here in this session is to convince you the emulator is actually your first port of call in this diagnostic. And to hear more from the Google Play team about how to use the latest Android Vitals to improve the quality of your apps and games, on Thursday at 2:30, we have a full session to go through all the new features and existing features. So with that, let me hand it back to Sam.
Thanks, Hoi and Frank. So that's a lot of information to remember, and I bet you guys remember them all, right? Just kidding. So let's recap. First, Android Emulator is pretty fast now, so you can actually get your test done quickly. Secondly, Android Emulator is pretty close to a physical device, so you can do most of the tests with it with confidence. Finally, Android Emulator is pretty flexible. It will help you to validate different API, different screen configuration quickly. So with that, we believe Android Emulator can be your go-to device for application development. One thing we like about Android is the open platform. Just like internet, permissionless innovation is possible. That's why we want to build Android Emulator to help. The new opportunity only possible because users like you actually create the new way to help the user. So hopefully, this will help you to find a new way to using Android Emulator to improve your productivity. Thank you for coming, and enjoy the rest of I/O.